Now let us try to name the structure B. The structure B given to us is like this. And again this structure is also a bonded line structure, and as you can see in the terminal position we have the presence of cyno as our functional group. CN means cyno, and with respect to this carbon atom we say a side chain. This side chain, because no other functional group is written there, is understood to be methyl group. So let us name this compound after analyzing the structure. Let us count the number of carbon atoms. 1, 2, 3 and 4. So this carbon chain is containing 4 carbon atoms. This carbon atom of the cyno will be taken as the suffix and we will be naming it as cyno. So when we name it as cyno, there is no need for us to count this carbon as the carbon belonging to the parent chain. So therefore we have only 4 carbon atoms here, and because there are 4 carbon atoms here, the root word to be fixed is but. And because this is again a saturated hydrocarbon, the suffix to be used is ane. What else do we see? We see the presence of a methyl group, and we also have the presence of cyno group. So C comes first in the order. So therefore I should write the cyno here in the front. This would be the first prefix. Cyno. Where is the cyno? It is attached to the first carbon atom. This carbon atom is containing the cyno as its side chain structure there. So therefore whether I write the locant 1 or no, it is not going to matter as much. So as well we can still retain the name as cyno. And with respect to second carbon atom, there is presence of methyl group. So cyno 2-methyl butane would be the name of this compound. 2-cyno 2-methyl butane would be the name of this compound. Is there any other possibility of naming the same structure? Yes, we do have. In case if we consider the carbon atom of the cyno group as belonging to the parent chain, then we would be counting this also. Therefore, our root word to be used is 1, 2, 3, 4, 5. 5 carbon atoms. So the root word to be used is pentane. Root word used is pent and ane because it is saturated hydrocarbon. So pentane, what kind of pentane is it? So 1, 2, 3. For the third carbon atom, there is attachment of methyl group. So therefore 3-methyl pentane nitrile. For CN, either we can represent it as a prefix as cyno. When we name it as cyno, we need not have to count the carbon atom of cyno as belonging to the parent chain. In case if we need to name it as nitrile, at that time nitrile covers the name of only the nitrogen and not the carbon. So at that time we should take the carbon atom of the cyno group as belonging to the parent chain. Therefore our root word increases by 1 count. So therefore instead of but, we should have to name it as pent. And because it is saturated, we have named it as A. So pentane is fixed. And 1, 2, 3. So in that case, this carbon atom would be third carbon atom. And this carbon atom, which is the third carbon atom, is containing the side chain, that is the methyl. So we call this as 3-methyl pentane nitrile. Both the names are accepted IUPAC names for this particular compound that is given to us. Now let us try naming the C problem of the same question. So the given structure is like this. So let us analyze how many carbon atoms are there in this bond line structure. 1, 2, 3, 4, 5, 6 and 7. So we are having the presence of 7 carbon atoms in this carbon chain given to us. So therefore the root word to be used, as you all know, is hept. Again, in the structure given to us, we find presence of singly covalently bonded carbon atoms, and hence the suffix to be used is ane. So heptane is fixed. What else do we see in the structure? There are 2 side chains. So what would be the side chains containing? Obviously methyl group, because no other functional group is being marked there in the structure. So therefore obviously these 2 ends would be carrying the methyl group. Then how to give the locants? Obviously from our left, because if we give from our left, this carbon atom would be taking the number as 2. In case if we give it from our right, what might happen? 1, 2, 3. So the first locant would be 3. So which is lesser number? 2 or 3? Yes, again it is 2. So therefore let us start giving the locant from this end. 1, 2, 3, 4, 5, 6 and 7. This is how the locant has to be allotted for this structure. So with respect to the second carbon atom and with respect to the fifth carbon atom, we find the presence of 2 methyl group. So therefore 2 methyl group are there. We need to give the locant of both the methyl group carbon atom, and we should have to use the prefix as di before methyl. Therefore 2, 5 dimethyl heptane would be the name of the given structure. Now structure D. Now look at the carbon chain given to us. Let us count the number of carbon atoms in the given chain. 1, 2, 3, 4, 5, 6 and 7. So the given carbon chain is carrying 7 carbon atoms in it, and it is a saturated hydrocarbon. So therefore the root word to be used is het and the suffix to be used is ane. So we have fixed the main chain of the carbon atoms, or the parent chain of carbon atoms, and we have named it. What else has to be done in the structure? As you can see, there are 2 functional groups that are present. 2 different halogen members are present in the structure. And the beauty is, both these different halogen groups are attached to the same carbon atom, and that carbon atom is number 3. So this is the chloro and this is the bromo. So which should be written first? B comes first in the alphabetical order, then comes C. So obviously the name while we are writing should be bromo first, and then we should write the name of chloro. So therefore the name of this chain would be 3 bromo, then 3 chloro heptane. The structure E given to us is like this. Take a proper look at the structure and let us first analyze what are all the things that are given to us. As you can see, in our left terminal position, we have the presence of Cl, that is the chloro, as one functional group, and to our right side terminal, we find the presence of C linked with double bond with O and C linked with a single bond with hydrogen. So obviously CHO, that means the functional group at the other end is aldehyde. So therefore let us start numbering the carbon atoms, and since aldehyde group has to be given the top priority, we should count that carbon atom as the first carbon atom. So after doing that, what do we have? 1, 2, 3. So this parent chain is containing only 3 carbon atoms. And what else is there? For the third carbon atom, there is a chloro that is being attached. So therefore, because it is containing 3 carbon atoms, the root word to be fixed is prop. And because it is saturated carbon chain, you need to look at the carbon chain and not this carbon and oxygen. Carbon and oxygen can contain double bond, and that will not help us to name it as an alkene. Only if there is a double bond existence between any 2 carbon atoms, then only we can call the compound as an alkene. So therefore, though you see a presence of double bond between carbon and oxygen, this is not an alkene. That is the double bond linkage of the functional group, that is the aldehyde. So therefore, the suffix to be used is propane. And because it is the aldehyde which is present there, I should not end it with the term E. This E of the alkane has to be replaced with Al. Aldehyde should end with the suffix as Al. So propanol takes care of the aldehyde and all these 3 carbon atoms. What else do we see? With respect to third carbon atom, there is a chain which is carrying the chloro as one more functional group. So therefore, the name of this compound would be 3-chloro propanol. Now, structure of the F. So far, we were dealing with the bond line structure, and in this case, they were given us the condensed formula of the organic compound. Take a proper look at this particular structure and note what are all the things that we see. You can see the presence of 2 chlorine atoms and the presence of OH as another functional group, and this carbon chain is containing only 2 carbon atoms. So therefore, the root word to be used is eth. Since there are no double or triple bond between these carbon atoms, obviously the given compound is a saturated hydrocarbon. So therefore, suffix an can be fixed. But then we have the presence of 2 Cl group and then 1 OH group. And where is this 2 Cl group present? So with respect to the first carbon atom, because if we number it from this side, lowest sum rule cannot be applied properly. So as a result of that, in order to satisfy the lowest sum rule, we have to number it from our left. When we do so, this carbon atom will be taking the number as 1. Because there are 2 chloro groups here, I should have to write the same locant one 2 times. 1, 1. Then what do we have? 2-chloro. So therefore I should name it as dichloro. 1, 1, dichloro. And what else is there? This OH has to be accommodated and that becomes the secondary suffix. Secondary suffix is written by replacing the E with that term OL. So therefore the name of the given organic compound would be 1, 1 dichloroethanol. Let us take up the next question. Question number 12.5. Let us first understand what is being asked. Here they are asking us which of the following represents the correct IUPAC name for the compounds concerned. Means they have given us the different possible names of which we should find out which would be the correct IUPAC name of the compounds. We need to find this out based on all the rules that we have learned. So, if you want, you can just quickly recollect all the IUPAC rules of nomenclature. Now, let us take up the first. A. The question is 2,2 dimethyl pentane the correct IUPAC name, or is 2-dimethyl pentane the correct name? Now here 2,2 dimethyl or simply only one locant as 2 and then writing the prefix as dimethyl is correct. We know that when there are two alike groups are present, we use the term as di or the prefix as di. When we write the term di, definitely we should give 2 locants. Though methyl group, both the methyl groups are present with respect to the same carbon atom as 2, still we should write it as 2, 2. This only will indicate that there are 2 methyl groups present for the same carbon atom. Here simply writing it as simply 2 indicates that only one methyl group is present with respect to second carbon atom. This does not convey the position of the placement of another methyl group. Hence, this name, that is 2,2 dimethyl pentane would be the correct IUPAC name in this particular question. So, continuation with the same question, part B. Now, take a look at these 2 names given to us. The first part of this name is 2, 4, 7 trimethyl octane. Then the second part of the name given to us is 2, 5, 7 trimethyl octane. Though we don't see the difference in the complete name, still we are seeing a difference in the locants that are being allocated for the 3-methyl group that is present in a carbon chain containing 8 carbon atoms, and it is a saturated hydrocarbon. Now which one would be the correct name? Now 4 is less than 5. So therefore applying the lowest sum rule, the name 2, 4, 7 trimethyl octane would be the correct IUPAC nomenclature of this compound and not 2, 5, 7 trimethyl octane. Now For the same question, part C. Look at these two names given to us. The first name reads like this: 2-chloro-4-methyl-pentane. And the second name given to us in the part C reads as 4-chloro-2-methyl-pentane. Now which one of them would be the correct name? So here it's giving a clear idea that there are two substituents being attached to the 5-carbon atom chain pentane. 5-carbon atom chain, and it is a saturated hydrocarbon, and these two substituents are attached at equal positions. So how to name when such cases are there? This we have previously discussed also. Now again I repeat. In case if we have the substituents at equal positions, then we should give that substituent which comes alphabetically the first lowest number, and then the next number for that next alphabet which comes in the alphabetical order. So therefore, when we apply this rule, the correct name would be 2-chloro-4-methyl-pentane, because C comes first than M. So therefore, C should be given the lowest possible number and the next possible number for this M. So when that being the case, 2-chloro-4-methyl-pentane would be the correct name. Why not this name is correct? As you know, chloro, C comes first. If we give the locant as 4, then that is not the lowest number. So therefore, this name would not be the correct name. This name, namely 2-chloro-4-methyl-pentane, would be the correct IUPAC name of this compound. Now let us discuss part D of the same question 12.5. Now look at these two names given to us. The first name given is but3I1-ol, means between the third and the fourth carbon atom position there is presence of triple covalent bond, and with respect to first carbon atom there is presence of the OH group, the hydroxy group or the alcohol group. Now look at this structure. But4-ol 1-ine. Now which one of them would be the correct name? Here, ine is the primary suffix and ol is the secondary suffix. Primary suffix gives the information as to whether given hydrocarbon is saturated or unsaturated. Secondary suffix gives us an idea about the type of the functional group present in the given organic compound. So always primary suffix should come first, then the secondary suffix. So therefore the correct name of the compound would be but3I and 1-ol and not but4-ol 1-ine, because in this order not only the hydroxyl group has got the highest number, which is not to be followed as per the multiple functional groups are present. One mistake. The second mistake is the secondary suffix has come first and then the primary suffix has been named. So in any way we see this name but4-ol 1-ine would be the wrong name, and the correct name would be but3I and 1-ol. Now let us discuss the next question 12.6. Here they are asking us draw formulas for the first 5 members of each homologous series beginning with the following compounds. they have given one of the compound in that particular homologous series, and they want us to write the first 5 members. That means preceding 4 members of that, follower members of that, and then we are also supposed to name them. Homologous series is the clue for us. So, every successive member of the same homologous series will differ by a CH2 group. A CH2 group is called the methylene group. So, every successive member will differ by a CH2 group or a methylene group. So, the starting given to us is HCOOH. The name of this compound is formic acid, common name, and methanoic acid is its IUPAC nomenclature. Methanoic acid. The next member would be CH3COOH. Add CH2 for this, then you will get this member. The name of this is ethanoic acid. Ethanoic acid. Then add one more CH to this, then you will get the next member of the same homologous series. CH3, CH2, COOH is the molecular formula, and the name of this compound is propanoic acid. Propanoic acid. Then you add one more CH to this, then you get the next higher member CH3, CH2, one more CH2, then COOH. The next member name is, because 1, 2, 3, 4 carbon atoms, the name of this compound would be butanoic acid. Butanoic acid. To this you add one more CH2, then the next member we will be getting, so CH3, CH2, CH2, one more CH2, then COOH. So as you can see, 1, 2, 3, 4, 5 carbon atoms are there, and carboxylic acid is the functional group. So therefore, the name of this compound would be pentanoic acid. So now take a proper look of all the 5 members of the same homologous series, starting from methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and pentanoic acid.